I scored one fraud model two ways. Offline, it came back at 0.88. Against the next 2 weeks of live traffic, it was a coin flip. Literally, AUC measures ranking and 0.5 is what you score by ranking at random. Nothing about the model changed between those two numbers. Same configuration, same rows, same features, same random state. The only thing I moved was the line between training and test. Every digit here comes from one seeded script you can run yourself. It's a world I built as an existence proof, not real card traffic. The gap is 0.36 and it's sitting in a default argument. By the end, you'll know how to check yours. Here's everything the model will ever see. 1,000 card transactions across 10 weeks, 250 cards, 4 transactions each, and every card lives in a burst of about 2 weeks before it goes quiet. That's the detail that matters. Entities repeat, and they repeat close together in time. 3 features per row: the amount, the hour, and a device fingerprint. I kept the fingerprint constant per card and tied it to that card's real risk, so it's on a signal, and it's also a name tag. About 1 row in 3 is fraud, which is high on purpose. Card 118 is the one I'll follow. 4 transactions, 2 in week 4, 2 in week 5. Now evaluate it the way everyone does. Shuffle the rows, hold out 20%, fit, score. Leakage is using information at training or evaluation time that you wouldn't have at prediction time. That's a whole definition, and the shuffle just bought me some. Every row keeps its week number, but the split doesn't read it. It sees a pile of rows, not a history. So training gets a week 10 row, while test gets a week 1 row. Those are the real extremes of my run. The model gets fitted on the future and graded on the past. Production never offers that trade. Time order isn't all the shuffle broke. Follow card 118. Under the shuffle, 3 of its 4 transactions land in training and the 4th lands in test. I didn't arrange that. The seeded split does it, and the script asserts it on every run. The fingerprint belongs to the card. So that identical value now sits on both sides of the line. When the model meets that 4th row, it isn't weighing the amount or the hour. It's reading the name tag, and it knows what the tag did 3 times in training. Scoring that row isn't prediction. The model is remembering it. 98% of shuffled test rows share a card with a training row. So 98% of my grade is a memory test. A random split straddles repeat entities by default. Group K fold and group shuffle split take a group's argument and keep every row of a card on one side of the line. That kills this leak. Hold that thought though, because it wouldn't touch the next one. Here's the entire evaluation. 6 lines, look at the split call. There's no shuffle argument in it. There doesn't need to be, because shuffle equals true is the default. You get it by writing nothing at all, which is why it never shows up in a diff or in review. Run it and it prints 0.884. That's not a bug. The arithmetic is perfect and the test set is genuinely held out. It answers the question I asked. How well does this model label a random sample of my own history? Nobody deploys to a random sample of their own history. And the test set can't warn me because the same line that broke it built it. So put every row back on the timeline and cut once at the end of week 8. Train on weeks 1 through 8, tests on 9 and 10. I didn't choose the test size either. Those 2 weeks hold 291 rows. The calendar picked that, not me. The model has never seen any of them, and it's mostly never seen their card twins either. The twin share drops from 98% to 15%, because a card that only lives 2 weeks rarely straddles the cut. Card 118 stays on the training side. The 15% that survive are cards who burst lands on the boundary, which is what a real calendar hands you. One cut removed both advantages at once. Same rows, same features, same configuration, only the split moved. New score, 0.523. That's not a verdict on the model, it's the first honest estimate of it. Why that low? Because the world moved. For the first 8 weeks, fraud here follows the amount. From week 9 on, it follows the hour. Amount stops predicting fraud, and the hour starts. Same columns, new relationship to the label. That's concept drift. And the shipped model is answering with a rule that expired. I put the rotation at week 8 and I cut at week 8. So my live window is entirely new regime. I built the world so I know where the pattern turns. You won't. You don't need to. Holding out your most recent weeks tests the model against whatever the world did last, named or not. And the shuffled test couldn't have caught it. Not bad luck. Arithmetic. A shuffle test set draws rows in proportion to history, so only 28% of its rows came from after the drift. 72% of my grade was the old regime, while live traffic is 100% the new one. So even a leak-free shuffle grouped by card would still have graded me mostly on a world that had already ended. Group-aware splitting fixes recognition. It doesn't fix the calendar, only time does. Offline evaluation asks how well you labeled a frozen sample of the past. Production asks how well you act on traffic that doesn't exist yet. The model didn't change, the question did. That question has a Q attached. This model ships at the end of week 8, and across the 2 live weeks, it scores 38 frauds below the median score it gave live traffic. Ranked in the safest half by the model that shipped, the largest is worth $165 and change in week 10. Be precise about the blame. Those misses aren't the shuffle's fault. The shuffle didn't build the model. It just graded it on the wrong world. What it cost me was knowing. And the dashboard read 0.88 while it happened. That number isn't just wrong, it's confident. One boundary, serving skew and feedback loops also break production models by different mechanisms in other videos. This run shows the split and nothing else. The fix is one line. Delete the shuffle, mask on the weak column, hold out 9 and 10. Now read the ledger. The gap is 0.361 and it has 2 receipts. Receipt 1, recognition. 98% of shuffled test rows had a card twin in training against 15% under the cut. That's card 1, 18's 4th transaction, 196 times over. Receipt 2, the calendar. 72% of that shuffled grade came from before the drift, while live traffic is entirely after it. And to be fair to the shuffle, random splits are correct when your rows are exchangeable. If any row could have arrived in any order and no entity repeats, shuffling is right. And splitting on time just costs you data. User event data almost never meets that bar because users repeat and the world drifts. The metric never lied to me. It answered the question I asked it. The honest answer was sitting on my laptop before anything shipped, 1 line away. The random split just made sure I never had to look at it. So go open your evaluation code and find the split. Ask what it's actually holding out. Ask whether a row in your test set has a twin in training. Ask whether anything you trained on happened after anything you're testing on. And ask whether the world your test set describes is the world you're deploying into. Split a long time, group by entity, expect the number to drop and let it. The real question isn't how good your model is. It's which question your split just asked.